Hey everybody, I'd like to do a little bit on cross-validation and at least go through the 66, 34, 33 split that I want you guys to do on your data. So cross-validation is all about checking the overfit of your model. Now, in linear model fit, you're not going to have a lot of overfit, um, but the cross-validation methods that we're going to discuss in this class become super important as you get into more crazier, especially non-parametric model fitting. There's a lot of really weird things you can do, and what happens is if you data snoop too much, um, well, let's show a picture, right? So we could, sorry guys, I'm trying to find a good picture here. We could essentially, draw a line that went through every one of these blue points, right? Not a line, a curve. So our function would be way overfit. It would perfectly predict every one of these. So we want to avoid that. Of course, a line's not going to do that. The linear model's not going to do that. But sometimes your linear model can be overfit. So cross-validation, this idea is to get around that. Okay, so the first thing I got to mention about cross-validation is you need a library called the caret. The only place I'm going to use the caret is right here. It creates the data partition. I've done an assignment here. Remember that the team that had 0 points, the team that hadn't played a game yet? Well, I went ahead and since it had NAs there, I put them as zeros for points and wins because I thought it was important to have that in my data. Um, I create a data partition then using the rank. The rank is it's just like a number that was assigned uniquely to every one of the teams. You might use ID here. You might use something that's pretty non-trivial, but I think it needed to be a number because I tried to use I tried to use the field that was the team names, and that didn't work. So, but what you see here is in this resample one, and I've only asked it to do one. It just tells me, all right, well, the first slot is actually team number 2. The second slot is team 3. Let's see, down here we skip the 30th team. We skip the 22nd team. But this is going to represent about 2/3 of all the teams. So that's what I've done here. And I've done this randomly, although if I hit refresh, it doesn't do anything different. I had set my seed somewhere. So it's random, it's pseudo-random, but because the seed's set, it doesn't change each time. And I do suggest you set your seed. Okay, so then there are 2 things I can do. I can, there's a lot of things I can do now, right? So I'm going to go ahead and call my data. I'm going to grab the training data. So we want to train the data on the 2/3, and we want to test the data on the remaining 1/3. So I split my data into the training data. And so here I'm just calling data, and then I'm asking it to look for these training samples, comma and blank, and then close the square brackets. And then I do a minus, which is like a not in R, not in the training sample. And that's what I call my test data. And boom, there's my test data. So you can see, like, yeah, it did work. It's only 8 teams, so it's out of the 31, that's about a third. Like I said, about. So there we go. Cool. What's next? Let's see. Next, I'm going to run my linear model. And again, I'm looking for wins based on the number of points. And the data I'm going to call is the training data. So that's why it's called the training data, right? Because that's going to train our model. And then I have it print the summary of the model. I name it model, and I print the summary of the model. So I don't know. You can look at some of this stuff here. We've talked about this already, but the estimate for points is about half, which makes a lot of sense. Intercept somewhere near 0, which is good. Intercept isn't terribly good, but the points coefficient is very good. You can call the plot of the model. We can do all that stuff, but I'm not terribly interested in that. We talked about that on the other video about the regression and doing linear regression. What I am curious about is actually making this work and getting some pictures, showing you guys what I did. So the next thing that I do is I actually go ahead and add a new column to my data, and I say whether it was test or train. And if it was in the training data, if it was in the training samples, I call it train on this new column. And if it was not in the training samples on this new column, I call it test. And so if I run that cell, you see a bunch of train, 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 test, test, etc., etc., etc. So we should see that, and that should match up, right? By the way, I'm weirded out because I don't see, well, whatever. Moving on. Okay, so, all right, so the next thing that I did, I played around with this. This took me a long time to make this one work, so I'm not so worried if you guys understand this code here. Let's just say I set up two colors, demanded that it only use those two colors. Then I plotted the points as the X, the wins as the Y. I asked it to do filled in circles. I asked it to do color as factor on that test training data. And then I asked it to do the AB line that was the model. So here's this picture. I'm never impressed with the graphics from BASR, let's say that. Okay, so let's do it again. I'm going to load the library ggplot2, and then I'm going to ask it to do data equals data. That's the full data set. And then the mapping has the aesthetics of points for the X, wins for the Y, and color equals the test train column. That's why I did that. Then I'm going to ask it to jitter plot. So you could ask it just to plot. But if you actually look at these points very carefully up here, there's a whole bunch of them on top of each other. There should be 31 points, and there are not 31 points because some of them are on top of the others. Jitter will get away from that. You see how these are kind of near where they were. Like this one right here is kind of near where it was, but they're not exactly on there. And then I ask it to do geom smooth method, linear method. And that gives me the lines of best fit with confidence intervals on them. And it even tells me which one's the test and which one's the train. And remember, we named those. That's why I'm getting that. So this is very, very sharp, very quick way to do it. I really do suggest you guys do the ggplot2 package. All right, last thing, I want to do predictions. So once we have a model, the blue one here, the training model, we actually want to test it. So technically this red thing I shouldn't have done, because what I really want to do is I want to say, now listen, I did the training on this blue model. The red points, I want to make predictions of them. So here's how I do that, is that I call this function called predict, and I ask it to look at my model and look at my data that was in the testing, that's not in training. And I call that predictions or pre. Then I'm going to look, so let's hit execute. There you go. These are the predictions. The predictions of the numbers of wins for these different teams. So different predictions here. Then I'm going to have it do an R-squared value, comparing the predictions to the actual wins. And when I compute that, that gives me an R-squared value of about 0.83. So that's a pretty good R-squared value. But what we should be comparing that R-squared value, and what's important in the cross-validation, is that you compare this value to the value you got when you fit the model. So if I scroll up here, when I fit my model, I got an R-squared value of about 0.884 or 0.8878. Yeah, this one is probably the right one. Again, guys, there's a lot of different theories here. There's a lot of different ways you can look at this. But what I'm looking for is this value relatively close to this value? It shouldn't wildly vary. So this is 0.88 and this is 0.83. So those end up being pretty close together, and that's a good estimate. But if you look, maybe this point seems to be pretty far down from the line. This point might be causing my problems there. That's why I really like the visualization. Okay, guys, so take a look and see what you can do with this, and keep working hard.